Hello, Math 2 students. So today we are going to be using factored form to graph quadratic equations. So the past couple weeks we've been working on factoring quadratic equations. Now we're going to actually use that factoring to our advantage and use it to learn something about the quadratic equation. So it says solve function f of x equals x squared minus 2x minus 8 by factoring. Then use the solutions to graph the function. So first off, what do they mean by the solutions? Well, to get the solutions of a quadratic equation, you're going to set it equal to 0. So you start with 0 equals x squared minus 2x minus 8. Now at this point, what you're going to want to do is factor. All right, so I have to figure out what two numbers are going to multiply to give me negative 8 and add to give me negative 2. That is going to be negative 4 and positive 2. So I'm going to keep my 0 equals, and I'm going to write out my two factors, which are x minus 4 and x plus 2. All right, now to find the solutions of this graph, what is going on here, right? We have two binomials multiplying to equal 0. All right. Now, one rule that we know in math is that when you multiply anything by 0, you're going to get 0. So if this binomial equals 0, that means that the function is going to equal 0. Or if this binomial equals 0, that means that the function is going to equal 0. So we're going to go ahead and set each of these binomials equal to 0. So we get x minus 4 equals 0 and x plus 2 equals 0. Then we get x equals 4 and x equals negative 2. So these are the two solutions to the quadratic function. All right. Now, to actually find the zeros themselves, they're going to be 4, 0, and negative 2, 0. Now let's go ahead and plot these. All right, we got 4, 0, and negative 2, 0. 1, 2, 3, 4. 1, 2. All right, so those are my two zeros. So now let's go ahead. We're going to take a peek at a Desmos graph of this function. Oop, looks like it restarted, and I have to replug it in. How fun. So it's y equals x squared minus 2x minus 8. All right, so if we look at the graph of this function, look, it hits the x-axis at negative 2, 0 and hits the x-axis at 4, 0. All right, so you can get these two x-intercepts by factoring and setting equal to 0. Now, another piece of information that is very useful. How do you find the vertex from standard form? So if we look, this right here is called standard form, right? That's ax squared plus bx plus c. And you have to do, you have to find the vertex by doing negative b over 2a. So what does that mean? Well, our b value is 2. So we're going to do, our b value is negative 2. All right, so we're going to do negative 2 all over 2 times a, which is 1. All right, there's an imaginary 1 here in front. So we end up with 2 over 2, which gives us 1. All right, then we're going to go ahead and plug this 1 in there. So this 1 is our x value, and now we got to find our y value of our vertex. So we're going to plug it in. So we get 1 squared minus 2 times 1 minus 8. So we get 1 minus 2 minus 8, which is going to give us a negative 9. All right, so we go ahead and now we've got our vertex, which is 1, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and we can go ahead and graph that parabola. Now let's go ahead and check. We can go check our vertex. Notice how our vertex was at 1, negative 9. It is important to know how to do this from standard form. You could also complete the square. But personally, I think this is a little bit quicker, and this is probably something you would want to know for the SAT. All right. So just to recap what we did today, we factored our quadratic function, set each of the factors equal to 0, and got the zeros. or the solutions of the function. Now, one thing I want to point out, solutions, x-intercept, 0, and roots all mean the same thing. So if you're ever asked, what are the roots of the function? What are the zeros of the function? What are the x-intercepts? What are the solutions? This is how you find it. You factor, you set equal to 0. All right. Next it says, solve each function by graphing. You may need to factor first. All right. So looking at this guy, all right, we need to solve this function by graphing. So, or I should say solve, we're going to solve first by factoring, all right? So looking at this, I can take out a greatest common factor here, which is going to be x, all right? So now I have x times x plus 5. So now I'm going to set each of those factors equal to 0. So I get x equals 0 and x equals negative 5. So my two zeros will be 0, 0 and negative 5, 0. All right, so we can do 0, 0, 1, 2, 3, 4, 5, negative 5, 0. And then to find our vertex, we're going to do negative b all over 2a. So that's going to be, our b is positive 5, so we're going to do negative 5. And our a is 1, so we're going to do 2 times 1. So we end up with negative 5 over 2. All right. And then we need to plug that into the function. So we're going to have negative 5 over 2 squared plus 5 times negative 5 over 2. All right. So let's plug that in. Plus 5 times negative 5 divided by 2. And I got, I love when my calculator freaks out. Fun. All right. I got negative 6 or negative 6.25. So the vertex is going to be negative 5 over 2, which is the same as negative 2.5. Then we get negative 6.25. So we got 1, 2, and then 1, 2, 3, 4, 5, 6. And that is going to be our vertex there. All right. So they asked for the vertex here, which was negative 2.5, negative 6.25. And how did we get that? We did negative b all over 2a, and we plugged that into the function to get our y value. Now it asks for the axis of symmetry. Hopefully you guys remember what the axis of symmetry is, right? That's that line that goes right through the vertex, and it goes vertically. Here the axis of symmetry is going to be x equals negative 2.5. All right. The zeros are the roots. That is going to be that 0, 0 and that negative 5, 0. All right. And if you recall from the beginning, solutions, x-intercepts, zeros, and roots mean the same thing. So here it asks for the x-intercept, so it's the same thing, 0, 0 and negative 5, comma 0. All right. Let's go ahead and try the next one. So, of course, we need to factor this again, right? So I have to figure out what multiplies to give me 8 and is going to add to give me a positive 6. So that's going to be a 4 and a 2. So I have x plus 4, x plus 2. Now I'm going to set each of these equal to 0. Oops. So I get x equals negative 4 and x equals negative 2. So my two zeros are going to be negative 4 comma 0 and negative 2 comma 0. 1, 2, 3, 4. 1, 2. It's going to be an interesting looking dude. And let's go ahead and find out the vertex. So again, we're going to do negative b all over 2a comma y. All right. So we're going to go ahead and our b is 6. So we're going to do negative 6 all over 2 times 1, which is going to give us a negative 3. So I'm going to plug in a negative 3. So we get negative 3 squared plus 6 times 3. I'm sorry, 6 times negative 3 plus 8. So we get 9 minus 18 plus 8. 9 minus 18 plus 8 is going to give us a negative 1. All right, so we get a negative 3, comma, negative 1. So that is our vertex right there. Our axis of symmetry is going to be x equals negative 3. And there are zeros slash roots are going to be negative 4, comma 0, negative 2, comma 0. And then we can go ahead, copy paste this. All right. So that's how you do when you start off in standard form. All right, you got to factor it, set it equal to 0, and get your zeros. Now let's go ahead and try this one. Now this one's kind of nice because it's already factored for you. All right, so we can go ahead and set these guys equal to 0 right away and get the zeros of our function. So we get x plus 6 equals 0 and x plus 1 equals 0. So we get x equals negative 6, x equals negative 1. So we can go ahead and plot those. 1, 2, 3, 4, 5, 6. And we get that. All right. Now you need to find the vertex. All right. So there's a couple different ways you could do this. What I would recommend doing would be just to FOIL this out and distribute. So I'm going to go ahead actually move this down there. Oops. So we're going to go ahead, FOIL this guy out, multiply those binomials. So we get 1/2 times x squared plus x plus 6x plus 6. So we get 1/2 x squared plus 7x plus 6. So we're going to end up with x squared plus 1/2 x squared plus 7 over 2x plus 3. All right. So now we have to go ahead and find our vertex. Now that we have it in standard form, we can go ahead and find our vertex, right? So we need that negative b. So we're going to have negative 7 over 2 all over 2 times 1/2, all right? So I'm going to plug that in, negative 7 over 2 divided by 2 times 1/2. And I got negative 3.5. All right, so now we're going to plug our negative 3.5 back into the function. So we can even do it with what we started with here. We got 1/2, negative 3.5 plus 6, negative 3.5 plus 1. All right, so we got 0.5, negative 3.5 plus 6 times negative 3.5 plus 1. And I got, kind of ugly. I got negative 3.125. All right. So our vertex here is going to be negative 3.5, comma, negative 3.125. All right. So let's go ahead and graph that. I'm going to actually go write that as my vertex here. Oops. All right, so there is our vertex there. So again, the axis of symmetry is going to be x equals negative 3.5. The zeros are what we already found, right? 0, comma, negative 6, 0, comma, negative 1, and then the x-intercept, same exact thing. That's just a different way of asking the same thing. So then we can go ahead and graph this parabola. Oops. Looks something like that. All right, last one here. This one's a little bit different. So we're going to go ahead and factor this. So this one, looking at it here, this is a difference of 2 squares. Hopefully you remember how to do those, right? So that's where you have to you look at it, you have a subtraction sign in the middle, and you can take the square root of both of these guys. So we're going to go ahead, take the square root of both of these guys, and we get x and 4. So we got to do x plus 4, x minus 4, and then we just set those equal to 0. X plus 4 equals 0, so we get x equals negative 4. X minus 4 equals 0, x equals 4. All right, so we've got our 2 zeros here. 1, 2, 3, 4, and 1, 2, 3, 4. All right, so we can go ahead here and find our vertex. So this one's actually kind of tricky. We're almost in standard form, all right? To get into standard form, all we have to do is distribute this. So you'd end up with like 1/2 x squared minus 8x. Oh, no, actually just 8. I'm sorry. So you distribute that, you get 1/2 x squared minus 8. And if you look, right, normally we're in ax squared plus bx plus c. There's no b. So that means that b equals 0. All right? So we're going to do negative b all over 2 times a, which is just going to give us 0. All right? So I can put that here. Our vertex is going to be 0 comma something. So now we're going to plug in a 0. So we get 1/2 times 0 squared minus 8. We're going to get negative 8. All right, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. All right, so that is our, wow, I can't draw these today. There we go. That is our parabola. Looks kind of more V-ish, but that's okay. The axis of symmetry is going to be at x equals 0. Our roots are 4, 0 and negative 4, 0. And our x-intercepts are 4, 0, negative 4, 0. So to summarize, today we learned how to find the zeros or the roots or the solutions of a function by factoring and setting equal to 0. And then we also learned how to find the vertex by using that negative b over 2a comma y.